I always start by saying focusing on only operational energy is a sub-optimization, because it means that you do not take into account the energy that was needed to construct the building, neither do you account for the energy that is needed to deconstruct or, as we said previously, demolish the building. So in that sense, that is really the aspect of circularity, taking this whole life cycle approach into account and looking even further, because that is the challenge between, or the difference between whole life carbon calculations and circularity. Whole life carbon looks really at the whole life of a building, and circularity looks beyond a single cycle. At this moment there are quite a significant number of challenges, because this is really still a field of research and development that is not very well established yet. So you see both technical barriers, both policy barriers, legislatory barriers, and as well market uptake barriers. So sometimes we speak to partners in projects and they say, we want to have a circular solution. And then we look around and there are no circular solutions yet available. So there's really a need for technical development of circular solutions. We see these challenges that, for instance, if you produce something that is circular in one country and you export it to another country, there's no problem. But then if you want to do reverse logistics, you meet national legislations, because then it's branded as waste, and then you have to follow the national waste legislation rules. So there you see as well there are clearly some legislatory challenges. And then from a market uptake perspective, nowadays a lot of circular solutions are more expensive. That has to do with economy of scale, but as well in many cases there is more labor necessary, for instance, to harvest materials, and that's something that we really have to change from a subsidy and taxing perspective. Lower taxes on labor, increased taxes on, for instance, CO2 emissions. The big difference between circular construction and traditional construction is that you really think ahead over multiple cycles. But before I joined VITO, I worked at the University of Applied Sciences, and we changed from teaching our students how to build buildings to think about how is the building going to be taken apart. So you really have to have a complete other way of thinking. If you look around at your buildings, don't think, hey, how am I going to put it together? How is it going to look like? No, think about multiple cycles. How can I take the building apart? And then looking maybe further back, then we're talking, for instance, about urban mining. Take a look back, take a look around, what is available in the existing building stock, and start using that as well in your design. So as an architect, do not start with making nice drawings and think, hey, I need windows of 2 by 2 meters. No, look at the availability of resources, of the availability of components, and start with designing with those. So that is really a mind shift that we still need to go through. There's no real clear adopted definition. So there are more than 140, 150 definitions of circularity in the built environment. So that already creates quite a diffuse interpretation of what is really circular and how can we guide circularity. Then going a little bit further and making it more concrete, if we look at the assessment of energy, there are clear assessment schemes for both operational energy, for an Energy Performance Building Directive, or LCA for the embodied energy and the embodied environmental impacts. But how exactly to cope with this multi-cycle perspective of using products over and over, that's still research work that amongst others we are doing in a couple of projects. So there's still quite some work to be done. That leads to two big challenges, overarching challenges. The first one is we see quite some greenwashing at the moment. Companies, organizations that say we have circular concrete, but what's really circular about it? That is quite difficult to judge. And the second thing is the topic of sufficiency, because we can make very circular solutions, very energy efficient solutions, but if that is completely offset by, for instance, using more materials or using creating bigger dwellings, creating more offices, then of course in the end we're on the wrong pathway. We really have to take the end users and all the people that are involved much better on board. So how can we do that? For instance, if we talk about circular solutions, really take the end user on board from the scratch of the project, from the scratch of the initiative, for instance with customer journey solutions, user experience based processes. So I think that from that perspective we really have to shift focus towards those end users, that they start adopting the solution from the start and really are part of creating the solutions. And actually we did a small investigation in that field in another European project. It was called Super Local, and what we did there is we invited a lot of inhabitants from the region to judge on the circular solutions, and it was quite interesting to see that they really liked the solutions that were circular invisible. So you wouldn't know that it would be circular, or that it would be very visible, like that it would be an added value. So maybe we can learn more from those experiences. There are quite a number of best practices, and that is really fascinating to be active in this field. That we see there's really a very large community involved, a lot of partners that really are making smaller and bigger steps. And so, for instance, I just mentioned the Super Local project where we investigated the reuse of complete apartment blocks. It was a European project. Now we're, for instance, involved in a European project called Drastic. What we're doing there is we have very big industrial partners, and some really directly have can have a huge impact on circularity and lower environmental impacts, because one solution is, for instance, can you reuse these ceiling plates? I'm looking up in the studio here. Can you reuse these ceiling plates? Because in essence the circularity potential is very big, but the whole business case is not built in that way. So that's what we're investigating. And can you, for instance, reuse steel beams? Harvest them from existing buildings, reuse them instead of remelting them and making new steel, because that creates, of course, a higher environmental impact.